everyone, my name is Inel and I'll be presenting our work on designing visual explanations for video summaries. This is joint work with Nava, Tintarev and Lora Aroyo on the Fairview project, a project supported by Google Digital News Initiative. One characteristic of today is the massive amount of digital content that people have unconditional access to. And this is especially remarkable in terms of video content. Latest stats show that only on YouTube, more than 500 hours of video are being uploaded every minute. This means that to be able to watch only the amount of videos that are being uploaded in a single day, one would need a lifetime. And so, even though we have effortless access to large amounts of video material, it is not trivial to meaningfully consume all the video content that we are surrounded by, and to understand which videos are actually relevant for us. Video summaries have been proposed as a typical solution to help users process this overwhelming amount of video material, because they can provide a quick look into long and dense video material. But there are many video summaries that can be generated for a single video. Short video fragments can be automatically selected and organized in lots of different storylines to summarize one and the same video. So, users are faced with condensed video summaries without understanding the underlying decisions taken to generate the summary, because the process is automated and not transparent to the user. This automated process to generate video summaries is prone to amplifying or diminishing certain aspects of the video, and might even omit meaningful information and lead to the misrepresentation of the original content. And thus, in this work, we focus on bringing transparency in video summarization to end users by answering the following research question. What kind of visual explanations are most useful to understand how representative a video summary is with regard to the original video? To answer this research question, we first conducted a small-scale survey with media professionals and audiovisual collection owners to gather insights on the characteristics of useful video summaries and effective interaction with video summaries by means of explanations. We found that study participants prefer a video summary in which the chronology of the scenes in the original video is preserved, because they find chronology to be strongly correlated with understanding the narrative of a video. They also prefer the video summary to be accompanied by the audio track and the link to the original video. Regarding video summary explanations, participants prefer short textual explanations that can be shown together with the video summary. As for the type of explanations, participants prefer to have an overview of both concepts that are covered in the video summary and concepts that are not covered in the video summary. Based on the type of video summary explanations preferred by study participants, we have derived a set of dimensions of transparency to make the representativeness of video summaries transparent to end users. The dimensions of transparency emphasize the importance of understanding the similarities and differences between summaries and original video in terms of semantics and quantities. Thus, we have semantic coverage, which refers to concepts covered in a video summary or concepts covered in the original video. The quantity coverage refers to the fraction of concepts covered and not covered in the summary. The semantic prominence refers to the concept prominence in a summary or in the original video, while distance refers to the difference between the summary and the original video. Having these 4 dimensions of transparency, we next focus on how to visually represent transparent explanations for video summary. First, we use word clouds, which represent well the dimensions of semantic coverage, semantic prominence, and distance. They can provide a quick overview of the concepts covered by the video summary. Furthermore, since our study participant had a strong preference for textual explanations, we consider word clouds to balance well text and graphics. Donut charts represent well the dimensions of quantity, coverage, and distance, and they offer a very quick overview of the total overlap of concepts between the original video and the summary. Based on the 4 dimensions of transparency and these 2 graphical representations, we designed the following visual explanations for video summaries. The explanation summary word cloud represents the semantic coverage and semantic prominence dimensions in the video summary. It summarizes the main concepts depicted in the video summary in a word cloud, where the concepts covered by the video summary are depicted with green color. The size of the words indicates the prominence of the concepts, which means that the larger the word, the more prominent the concept is in the video summary. The explanation overlap fraction represents the dimensions of quantity, coverage, and distance, and it summarizes the percentage of concepts in the original video that is covered by the video summary in green color, and the percentage of concepts in the original video that is not covered by the video summary in purple color, in a donut chart. Next, we have the explanation overlap word cloud, which represents the dimensions of semantic coverage, semantic prominence, and distance. This explanation summarizes the main concepts depicted in the video summary in green and the main concepts in the original video that are not covered by the summary in purple in the word cloud. The size of the words indicates the prominence of the concepts in the original video. And finally, we have the explanation combined word cloud and fraction, which represents all 4 dimensions of transparency, and it's a combination of the 2 previously introduced explanations. Now that we know how to design transparent visual explanations for video summaries, we explain how we automatically generate them. We start with extracting concepts from videos. First, we identify all labels from the video stream or from video frames, where a video frame refers to a 1-second video fragment. Then, we extract entities from the video subtitles. We refer to these labels and entities extracted as concepts in a general fashion. Since it would be difficult to visualize all concepts extracted from video subtitles and video frames in a word cloud, we then identify the key concepts from the 2 data sources. From labels in video frames, we select all labels that appear in all 3 portions of the video, namely beginning, middle, and end, and among these, we select the labels that have an occurrence higher than the median occurrence value in the video that is being analyzed. From entities in video subtitles, we select all entities of type people, organization, event, and location. Upon analysis, this selection gives us the most optimal set of named entities, which most likely will not appear among the video frames labels. Finally, after having the set of key concepts from video subtitles and video frames, we compute their prominence. We normalize the frequency of concepts in video subtitles and video frames by the maximum occurrence among each of them to have prominence values between 0 and 1 for both types of concepts. If a concept appears in both subtitles and frames, the word cloud shows the prominence from the subtitles. Now that we have a methodology for generating transparent visual explanations, how do we know that our approach actually works? First, we focus on measuring the utility of each visual explanation to help people assess the representativeness of video summaries with regard to the original video. We do this in an online user study on Amazon Mechanical Turk. We use 20 videos and one of their summaries of 10 seconds. Each pair of video and video summary was annotated by 20 participants. The study procedure followed the steps depicted here. First, the participants are asked to watch the full video. Then, they are asked to watch the full video summary. The video summary, it's important to remember here that the video summary is hidden from the participants unless the video has been finished playing. Similarly, the questions of the study are not available unless the video summary has finished playing. Then, we ask participants to inspect the 4 types of explanations, whose order was randomized each time, and choose the ones they find the most useful to understand how representative the video summary is for the original one. We also ask them to motivate their answer and to tell us which other visualizations they find useful for assessing representativeness. We found that the explanation combined word cloud and fraction received the most votes, and thus is the most preferred visual explanation. We concluded that participants prefer the most complete visual explanation that semantically characterizes and quantifies the overlap between the video summary and the original video, and it is also reflecting the differences between the two. The explanation overlap fraction was overall the least preferred visual explanation. This indicates that, in general, the quantity coverage dimension has the least representativeness utility when used alone. The summary word cloud explanation is also among the least preferred, especially when the original video contains many prominent concepts and only few are covered in the video summary. Now, the first study confirmed that the identified dimensions of transparency were helpful for assessing the representativeness of video summaries. However, we do not know how participants would use this information in practice. Thus, in a follow-up study, we compared 2 different video summaries of the same video and their combined word cloud and fraction explanation to see how the explanation can be used for comparison. We studied this also in an online study performed on Amazon Mechanical Turk. This time we used 18 videos, 2 of their summaries of 10 seconds, and their combined word cloud and fraction visual explanations. Each set was annotated again by 20 participants. The procedure of the study was the following. Participants first had to watch a full video and then the 2 video summaries of the video. Upon inspection of the video summaries and the visual explanations, they were asked to choose the most representative video summary and motivate their choice. To analyze the outcome of the study, we performed a qualitative analysis of the participants' comments. We found that each of the 4 dimensions of transparency were useful when assessing the representativeness of video summaries. More exactly, we found that the dimensions of semantic coverage and distance are useful to understand that the video summaries are not representative for the original video. Further, we found that although the dimension of quantity coverage has the least utility in assessing representativeness, it is still useful when the 2 summaries are very similar. And finally, the key concepts of the video, expressed by semantic coverage, semantic prominence, as well as distance, seem to be the main aspect of assessing representativeness of video summaries. We are making all the data and analysis presented in this paper available online. Even though we present only small case user studies with about 20 videos, we apply the methodology presented on a much larger dataset of 200 videos. Thus, we contribute a dataset of 200 videos and 800 video summaries, with 4 summaries per video, annotated with key concepts. Furthermore, for each video summary pair, we generate 4 visual explanations, resulting in a total of 3,200 visual explanations with different levels of transparency. Our work, however, is not over. From our 2 user studies, we concluded that video semantics play an important role in understanding the main concepts of a video. Thus, we plan to improve the detection of key video concepts. Furthermore, we plan to study the effect of the video summary duration. And finally, the participants of our first online study suggested some other visual representations that could be useful for assessing the representativeness of video summaries that we would like to experiment with. This brings me to the end of my presentation. I would like to thank you for your attention and give you a kind reminder on our published dataset.